Hello, students at Mary Baldwin College. We are now going to get to week 3, I believe. Here, we're going to talk statistics again. Instead of having our face-to-face class, we do it acoustically here again. And we're just going to follow the agenda. Your idea is to take notes on things, write up a good detailed outline so that you can have this information. I will get you to do a couple of problems just to demonstrate some simple competency, and then after all this is done, I'll review things for the test. So, week 3 agenda. We're going to start with an Ohio State example on the agenda here. So let's say that I was taking physics at Ohio State because it was 1982 and I was thinking I was going to become an engineer. And I was in a physics class, and it turns out I got a 45 on a test, 45 out of 100 on a test. And then I took a psychology test that semester and I got an 80. The question I have for you, and these were both on 100-point scales, how could I be very happy that I got a 45 on the physics test and got very upset that I got an 80 on the psychology test? So the question is, could this actually happen? And if so, how could that have happened? Well, the answer, as you can kind of see a little bit below that, is to really know how you did on something, relatively speaking. What's very important to know is how did the rest of the people do? In physics, and I don't know if any of you have ever taken physics, I did not excel at physics, but the idea isn't how smart you are according to 100 points per se, but how smart you are compared to the rest of the people in the class. Because basically everybody was lost in that class, so if I was a little less dumb than the others in the class, that would make me, of course, a genius. And indeed, that's actually how it worked out, that if you look at the information right below that, it says that I got a score of 45, but notice what it says mu was. Remember what mu is? The mean. The mean for the population, the mean in this case for the class, in the physics class, was a 40. So if I got a 45 and they all got 40, that means I did better than them. So this is a good thing, number one. If you look at the psychology class, the other group, it says I got an 80, but what was the mean for that group? That was a 90. So the main thing you need to do is, if you want to see how well did you do compared to a group, which is really the question we're asking here. So the issue in this particular chapter, I think it's chapter 5 here, is if you get a score and you want to know how you did relative to another group, you basically have to know what your score was, what the group mean is, and do you notice what the other bit of information is you need as well? It's the standard deviation. We'll get back to that in a little bit here. In order to figure out how you did relative, how one person did relative to a group, you've got to know what your score was, the X. You've got to know what the mean of that population is, mu. And then you also have to know something about the variability or the dispersion, sigma, the standard deviation. If you have those 3 bits of information, you can compute something that's considered somewhat useful for statisticians, a z-score. So a z-score is basically a transformation. And when you get a z-score, the idea is you can figure out how one person did in Chapter 5 relative to a group. So it's called a z-score distribution. And if you actually can do the math here, let's see if you can actually figure it out. For my physics situation, what was my z-score? Well, the mean was 40. I got a 45. And the standard D is 5, so my z-score for physics would be what? Hopefully you figure it out, plus 1. How about for psychology? What was my z-score for that? Well, my score was an 80, and see if you can figure this out yourself, and then compare it with what I tell you. My score was an 80, the mean was a 90, and the standard D was 10, so for psychology, my z-score was what? A -1. I give you these easy problems so you can better understand the nature of this formula here. So which test did I do better in? Yeah, plus 1. The physics situation, I did much better. If you get anything on the plus side, that means you did better than the average. If you get anything on the negative side, it means you did worse than the average. Let me ask you a third question here. What if I came home to my mom and dad and I said, well, I got a z-score of 0. What would a z-score of 0 mean? Well, if you figure it out, a z-score of 0 would mean I scored right at the mean. So if I got a score of 40 and the mean was 40, then my z-score would be 0. So Actually, let's follow that up just a little bit. If I got a z-score of 0, what percent of the class would we say did better than me? If I got a z-score of 0, what percent of the class could you say did better than I did? If I got a z-score of 0, if you got a z-score of 0, that means you got the score of the mean. That means you did better than 50% of the class, and 50% of the class did better than you. Can you kind of understand that idea? So if the mean of the class was 40 and I got a 40, then your z-score, no matter what the standard deviation is, would be 0. And the idea would be, oh, I did better than half the class and half the class did better than me. What about the z-score of +1? If you think about it, a z-score of +1, that means you did better than most of the people in the class. So you did better than 50%. It's probably even more than that in the class. So you can get a z-score, and from a z-score you can figure out who did better, who did worse, who did about the same as far as the class is concerned. So I hope that makes some sense for you. And actually, it looks like I put some information below there in C, I should say. Things we know about Z distribution. So this is just some information for you. If I was there for you right now, I would try to draw this up. Let's see if the book actually does this for you. Many times this class is a face-to-face class. Looks like if you turn to page 141 in version 9, and let's see what we got in version 8 here. 141. Yeah, it looks like 141 in version 8 as well. They kind of give you a picture down below, figure 5.3. And they kind of show you some information in those pictures. If you look at it, it's a normal curve. And the idea is, notice that if you get the score of mu, which is the U symbol in there, if you get that score, you get a z-score of 0. Notice what percent you do better than. You do better than 50%, and 50% do better than you. So that's a z-score of 0. Can you kind of see that there? Now the next thing, you'll have to kind of take my word on this first. Notice what happens in the physics situation. You get a z-score of 1. That means you did better than most of the people in the class. Notice the facts I've given you here. If you get a z-score of +1, that means you did better than 84% of the people. And I'll explain where that comes from in a minute. So the idea here is that if you get a z-score, we can know how good or bad you did relative to the group. If you read that section, 5.2, you can see the sign tells whether the score is above or below the mean. You want to be above the mean. And then the actual score you get there tells exactly how far from the mean you are. So, with that being said, I need to get a little drink of water here. Let's go to these other z-scores. I hope you can understand that if you get a z-score of 0, that means you did better than 50% and 50% did better than you. But let's look at the z-score of 1. The place I'll need you to go is actually the back of the book. And I'm on version 9 here, and I think they should be about the same. Versions 8 and 9. There should be some tables in the very back. Come on, tables. Or maybe not. Maybe I'm losing my mind. Huh. Well, I hope you're better at doing this than I am. I know there are tables in the back here. Appendix A, it looks like, I believe it's actually Appendix B here in the back. They have some tables in the very back of your book. It looks like version, here we go. Looks like version 9, it's on page 699 or so. For version 8, let's see what we got for version 8. Version 8, page 725. And if you'll notice there, if you go to those pages, 725 and 699, if you go to those pages, notice what we see in these tables. Look at the first row in that table. It says a z-score 0. What do you remember learning about a z-score of 0? You remember learning that the proportion in the body, kind of column B, you've got 50% to the left and 50% to the right. So that a z-score of 0 means that you've got half to the left and half to the right. Go down the first column, and it actually looks like it goes into the second column and then even the following page. See if you can find a z-score of 1. It looks like a z-score of 1 is on either page 700 or 726. A z-score of 1, notice what it says with a z-score of 1. The proportion in the body is 84%. So that basically means between the far left-hand side and +1, there's 84% of the distribution in, and it means that the proportion in the tail to the right of that spot is about 16%. So if you turn back to the book page on 141, if you go to a z-score of +1, that means that all the area under the curve to the left is 84%. It's got the 50% from 0 to the far left-hand side. And the area from 0 to +1 is basically 34%. That makes 84. And anywhere to the right of that, that represents 16% of the curve. So if you get a z-score of +1 on a distribution, that means you did better than 84% of the population. And it also means that 16% of the population did better than you. So that's certainly better than half. If you go to a z-score of 2, let's say you get a z-score of 2, that means if you look in the table again in the back of the book, that means you did better than 97% of the population, and about 2% did better than you. So the idea is the higher your z-score, the better off you actually did. So I hope that makes some sense. I think this would be better in person, but there's not much I can do about that since we're on the acoustics here. How about the score in psychology of -1? What does that mean? Well, to go to a score of -1, you'd have to go below the mean. And if you were at a score of -1, that would mean you only did better than 16% of the population, and 84% of the population did better than you. So I hope this makes some sense for you. I do have one problem that I can ask you to do. I'll actually verbally say the problem so that those of you who have the version 8 of the textbook can actually do this problem as well. This is on page 161. See if I can go to that page for you. And on page 161, it's chapter 5. It's the one problem. Let me read it out to you. I'll have everybody, if they can, do problem number 10. So let me read it out for you. It says, find the z-score corresponding to a score of x equals 60. So the idea is see if you can find a z-score for a score of x equals 60. For problem A, it says mu equals 50 and sigma equals 20. For problem B, mu equals 50 and sigma equals 10. For problem C, mu equals 50 and sigma equals 5. And for problem D, mu equals 50 and sigma equals 2. The other thing I would like to know about this from your perspective, I'm going to add on just a tiny bit from this. If you were in this class, assuming a high score would be good, which one of these 4 would be your best possible score? Which one of these 4 would be your best possible for? So just get a z-score and tell me which one would be the best one. So that kind of covers chapter 5 for us, z-scores. The idea is how do you compare with your group? You get a z-score by taking your score, subtracting it from the mean, and then dividing it by the standard deviation. The higher your z-score, the better. And we do know some facts about the distribution. We know that if you get a z-score of 0, you do better than 50%, and 50% do better than you. If you get a z-score of 1, you may just want to remember that you do better than 84%. And since under the curve is 100%, 16% do better than you. If you get a z-score of 2, that means you do better than 97%, and about 2.5% do better than you. We looked at that table in the back to kind of map that out, and this is what you need to know. Thank you.